Hello students, welcome to the new video on Analog Electronics 1. Myself Gunjan Mittal Roy in the Department of Electronics and Communication Engineering in GEMTech, Britain, Noida. In continuance to the previous videos on negative feedback, today in this video we will be covering the benefits, or in other words the properties of negative feedback in amplifiers. So here we are going to discuss about properties of negative feedback amplifier. So there are a number of properties of a negative feedback amplifier, and almost all the properties of negative feedback amplifier are advantageous for an amplifier. So in other words, we discuss about the advantages of negative feedback amplifier. So the very first advantage which we are talking about is gain stability. See, what is gain? Gain is the amplification factor of the input signal. Whatever voltage we apply at the input, we are looking for the magnified value of that input at output. So that is called the gain. So now the stability of gain means that whatever is the magnitude of gain, it should remain same throughout, whether the input voltage is changed or input conditions are changed, temperature is changed, environment is changed, timing is changed. So in all the conditions the gain should remain same. This is called as the gain stability. So stability of the gain is improved in negative feedback amplifier. And how it is improved? That the stability of the gain is improved in such a way that it becomes independent of beta factor. It becomes independent. So when this becomes independent of the beta factor, it becomes stable. So the changes are minimum and therefore the stability becomes maximum. After that, the second parameter is reduction in non-linear distortion. So first of all, what is non-linear distortion? It occurs when the device, which is the transistor, works in its non-linear region, and that non-linear region is the cutoff region. And it occurs when the device operates, the operating point of the device is close to the cutoff region. This is the case with the large signal amplifiers or power amplifiers. So in power amplifiers or large signal amplifiers, we observe a non-linear distortion in the form of amplitude. So the distortion is also nothing but the voltage, and this distortion is reduced in negative feedback amplifier. That means by providing negative feedback, the non-linear distortion is reduced by a factor which is 1 upon 1 plus A beta, or MV, where MV is showing the voltage factor in feedback path. So MV is the gain of the feedback path, which is the feedback factor, and AV is the voltage gain of the open loop circuit. So the closed loop gain we know is A upon 1 plus beta A, or 1 plus MV AV. Now with the use of negative feedback, the distortion voltage with feedback is given as dVf, that is equal to D upon 1 plus AVMV. So now 1 plus AVMV factor is considerably high value, and when it comes in denominator, definitely it reduces the value of dVf, which is the distortion voltage in feedback. So the feedback, with the application of the feedback, the distortion reduces. So this is the next parameter which improves if we apply negative feedback. The third parameter that improves is the frequency response. So in case of a negative feedback, the frequency band increases, the range of frequencies increases, It is because the lower cutoff frequency is much reduced and the upper cutoff frequency is much increased. And this occurs if the upper cutoff frequency becomes f into 1 plus beta a, and the lower cutoff frequency becomes f upon 1 plus beta a. So the lower frequency is much lower and the upper frequency is much higher, and that is how the range of the frequency is increased. Next is increases circuit stability. So the overall circuit becomes stable, and this is because the change of gain of the amplifier results in distortion, but by applying negative feedback the voltage gain of the amplifier is stabilized or fixed. So if the voltage gain is fixed, as we have discussed in the first advantage of negative feedback, then the circuit stability also increases. And stability means that the output does not change due to ambient temperature, frequency and amplitude of the signal. So the changes of these parameters do not affect the stability of the circuit whenever negative feedback is applied. Next parameter which is improved by applying negative feedback is impedance. Now the impedance of an amplifier should be such that it should be high at input port and low at output port. So if we apply voltage series feedback, which is shown in the circuit, with that the input impedance is increased and output impedance is decreased. The details of impedance consideration will be covered in next video. So as of now, for the when we are talking about the advantages or properties of negative feedback amplifier, we should remember that the input impedance of voltage series feedback amplifier increases, whereas the output impedance decreases. This is the derivation that the input impedance is increased by factor 1 plus AM, where A is the voltage gain and M is the feedback factor, and the output impedance is decreased by factor 1 plus AM just because it comes in denominator. So in input impedance Zn dash, which is showing the impedance with feedback, it is equal to Zn into 1 plus A into M, because 1 plus AM factor is coming in numerator, or it is simply multiplied with Zn, so it improves the overall input impedance, which is Zn F dash. Whereas in case of output impedance consideration, we can see from this equation that the output impedance Z out is divided by the factor 1 plus AM. So if it comes in denominator, the impedance factor is reduced. So we are getting both the desirable impedances, that input impedance is increased and output impedance is decreased. But this is not the case with all the 4 configurations of negative feedback. In fact, for all the 4 configurations, the impedance values are different. But the most suitable impedance parameters for an amplifier are obtained by using voltage series negative feedback amplifier. So this is the impedance consideration, which is the advantageous impedance consideration of voltage series feedback amplifier. So here we have some numericals that, like for first example, the voltage gain of an amplifier without feedback is 3000. Now calculate the voltage gain of the amplifier if negative feedback is introduced in the circuit, given that the feedback fraction MV is 0.01. So the feedback fraction MV is given to us, voltage gain is given to us, and we know the formula of voltage gain with feedback. It is equal to A upon 1 plus AM, and if we put both the values A and M, we get the voltage gain with feedback, which is 97 only. So here we can conclude that the gain with feedback is reduced. This is the only drawback of negative feedback amplifier, that the gain decreases. Another example is also considered. Here the overall gain of the multi-stage amplifier is 140. When negative feedback voltage is applied, the gain is reduced to 17.5. Find the fraction of the output that is fed back to the input. So we have got voltage gain without feedback, which is 140, and gain with feedback, it is 17.5. Now we have to determine the feedback fraction, which is MV here. So again we will use the same formula, AVF equal to AV upon 1 plus AVMV. Here we have the two parameters AV and AVF, so we can determine MV. Thank you so much.